Hello. Welcome. This is bringing your data to life in the ArcGIS API for JavaScript, vector tiles. I'm Craig Williams.
Jeremy Bartley.
And we're gonna talk about vector tiles. We'll start with an overview of vector tiles and talk about vector tiles in ArcGIS, not strictly from a JavaScript standpoint, but from a vector tile standpoint. We'll talk a little bit about consuming and styling vector tiles. Talk about creating vector tiles, which actually involves ArcGIS Pro, authoring that map as part of the creation exercise. And we'll talk a little bit more about vector tiles in the JavaScript API. Depending on what time we have for questions, we'll take those at the end. I do have a list of common questions that we get asked about vector tiles that I have answers for in slide form, just to give cleaner answers than me reciting them. You can follow along on those slides if we have time to get to there. Okay, just to start off, if you look at web and mobile mapping over the last 10, 15 years, we typically have vector content displayed on top of basemaps. Since 2005-ish, those basemaps have usually been raster tiles. If you wanted to update your map, you're either updating this overlay content or you're swapping out basemaps, recooking tile sets, things like that. And really this model is changing quite a bit. And one of the reasons it's changing is because of GPUs, graphics processing units. If you saw the plenary when Jan was up on stage showing a lot of behavior that's coming to the JavaScript API, a lot of that is GPU enabled. And in the browser, that's typically WebGL. WebGL 2's coming out soon as well with a lot of great new technology. We all have these magic rectangles in our pockets these days that always need charging, by the way. I'm charging. Those are usually OpenGL ES2 or ES3 on some of the newer devices. On your traditional desktop, if it's Windows, you're typically using DirectX. Everything else pretty much using OpenGL. And even if you're on a virtualized system, if you connect via Citrix or even Windows Terminal Services, we have some virtualized GPU behavior. Really what this does is help us accelerate draw by moving draw to the GPU. And in the case of vector tiles, your vector data can remain vector, but draw at the native resolution. So we're not dealing with pre-rendered tiles that were processed for one specific resolution. We're now bringing data to the device. And with high DPI devices like our mobile phones, our tablets, and even a lot of our laptops these days, we can draw at the native resolution for the best possible display. That said, I will say raster tiles are not going away. They're still useful for a lot of purposes, especially things that are raster by nature, imagery collected from satellites, things like terrain and hillshades that are continuous surfaces. So advantages of vector tiles, obviously display quality, but doing that high display quality in a small, efficient format. A lot of the early attempts to get high display quality on mobile devices dealt with high DPI tiles, sometimes called 2x tiles, because they were twice the dimension in X and Y, actually 4 times the size in number of pixels. And those are not great on mobile phone networks because you're downloading larger raster tiles. And with the capabilities we have on devices nowadays, bringing down vector data and actually drawing it on the device is a far more efficient solution. You can also do things like label dynamically in the device. So with a raster tile where text is burned into the raster, that's different in a vector tile world. In a vector tile world, we're labeling in the client. So as you rotate the map, labels can be oriented so that they're readable. In the vector tile specification, we also separate out the data storage from the symbolization. And that allows us to do more than one style on a single set of tiles. And we'll show that with the Esri vector basemaps, where we leverage one tile set and have many different displays of them. So vector tiles in ArcGIS are produced using ArcGIS Pro, and they're produced with, according to the Mapbox vector tile spec. The Mapbox vector tile spec is a protocol buffer definition, and Google protocol buffers is a binary serialization format that can be read in a variety of languages, cross-platform, etc. You essentially define a small schema, you run it through some code generation, it'll produce code in the language of your choice. And then the styling information of your map is in the Mapbox GL style spec. And the GL style spec is a JSON styling spec that defines things like the symbol colors, symbol behavior for scale dependency, and things like that. One of the things we do a bit differently in ArcGIS is leverage a concept called overzoom that exists in vector tiles, but we do it more aggressively. When you're dealing with vector basemap content, typically vector tiles are created from LOD 0 down to about LOD 15, and then past LOD 15, you're just zooming in on that LOD 15 tile. We're doing that because we're carrying vector content. We can draw that vector content through higher LODs without needing to duplicate storage across tiles. But what we did in ArcGIS is we did this more aggressively. If we're in a really sparse area and there aren't a lot of features, we'll actually stop creating tiles at a much lower level of detail, something like LOD 5. So this image I have here is sort of our tile density off the coast of California here, and you'll see out in the ocean, we don't go very far down in terms of levels of detail. It's not that we don't have features there, we actually have bathymetry in our base maps, so we have polygons, but we can carry the full resolution of that bathymetry polygon data in LOD 5 and carry that through the rest of your zoom ranges up to, say, LOD 20. And what this allows us to do is create fewer tiles when we create the vector tile package, and also download fewer tiles when we're rendering this on our devices. So it saves on both creation and rendering time. That said, if you're using an API to render vector tiles from ArcGIS that does not support this overzoom scheme, you can create tiles with the traditional tiling scheme that will create tiles uniformly down to LOD 15 and then overzoom after LOD 15.
So if you're using our JavaScript API, it'll support the overzoom that Craig's talking about. This would be like if you're using, Mapbox GL or something.
Yeah, Mapbox or OpenLayers has some support for vector tiles as well. Okay, vector tiles in ArcGIS, another difference is that we can produce vector tiles in any coordinate system that ArcGIS supports, and all the Esri clients, the JavaScript API, ArcGIS JavaScript API, ArcGIS Runtime, ArcGIS Pro, can support drawing tiles in any coordinate system. Most everybody else supports Web Mercator, and that's it. So that's not suitable for a lot of the use cases in ArcGIS, so we allow any coordinate system to be created. Some recent additions that we've done for vector tiles are additional support for data-driven workflows. These are attribute-driven symbology cases, and we've released those with Pro 2.1 and the 4.6 and 3.2.3 JavaScript APIs, and Runtime 100 Update 2. We've also added support for vector tiles in the print service with ArcGIS Enterprise 10.6. There's some caveats about that I'll talk about later towards the end of the presentation. And just to define some future work we're working on creating tiles from feature services. So creating vector tiles from feature services, somewhat similarly to how we create raster tiles from feature services. That's something Jeremy and his team is working on. We're working on pop-ups, so doing identify, and there's really two scenarios we're working on there. One is hitting an associated feature service to get rich attribution, and another one we're definitely doing for Pro and eventually Runtime is to hit the tiles and bring back the minimal attribution that exists in the tiles themselves. If you're familiar with the Mapbox GL style spec, there's a layer concept in there called the circle layer that's for really simple drawing of circular, basically point symbols. And we're adding support for that in the next releases of all of our APIs.
A little bit on the tiles from features. So what this will give you the ability to do will be to author your feature layer exactly how you want it in online or from Pro. Publish that, then you'll be able to go to that feature layer and publish it as a vector tile layer. And what it'll do is it'll create an association with that feature service, that feature layer backing. So you'll be able to get legends with your vector tiles, and you'll be able to get pop-ups that work with the pop-up that's in your feature service. So we're looking to roll that out at the UC in the Update and Online. So, yeah.
Okay, we'll dive a little bit into how vector tiles work. So the vector tile format, I said, is a protocol buffer specification. If you were to crack open the binary in an individual tile, you'll see that it's data that's organized by essentially layers of geometry with key value pairs of attributes. It's actually called a feature in the vector tile specification, but it's not a full-fledged GIS feature. It's really just the minimal attribution and geometry needed to draw on the map. And in almost all cases, that geometry will be heavily generalized for the level of detail you're looking at the tile for. And then if you were to look at the style JSON contains sort of the layer drawing order. You can have filters for symbol layers. Obviously, the actual symbol information for each symbol layer. And we convert maps from ArcGIS Pro into this styling spec. It will be a downgrade in many cases. The GL style spec is engineered to draw on the GPU, which means that drawing instructions are executed via shaders, and those shaders are somewhat limited in what they can do compared to the software rendering we see in ArcGIS Pro. So you'll see limitations in some cases. If you're going to be publishing a map from ArcGIS Pro that maybe has some complex symbology, we recommend that you make a sort of test scenario first to see how well that comes across before committing to a larger tile creation job. All right. So talk a little bit about history of Esri basemaps created with vector tiles. And to create vector tiles for the whole world takes, these are updated stats for our most recent basemaps, takes around 10 hours on a desktop machine under somebody's desk. We're not talking server clusters here. Our tile set's about 25 gigabytes, but multiple styles of the vector tile basemaps can use the same tile set. So that is very different than what it's like for our raster tiles. Our raster tiles we have to create on giant server clusters, and we're talking terabytes of data. So vector tiles, much different and easier to handle. 25 gigabytes, I could put that on my phone, for the whole world. I'm not going to do that with 20 terabytes. So orders of magnitude difference.
And the amount of effort it takes to manage and build out that raster tile cooking is...
Yeah, we have an entire team to build our raster tiles. There's one person who builds our vector tiles.
Yeah.
And she just spins it up and creates the tiles when we have updates, and it's good to go.
One thing is the raster tiles do hide bad data. You have some good examples. Right?
Yeah. So when we first started our vector tile basemaps, we were analyzing the size of the tiles and seeing what was too large. And one of the classic cases was a city down, I think it was somewhere in Mexico. We had some building data, and there wasn't much in the tile visually. I mean, it looked very simple. But when we dug into the vector tile, we saw that the building was repeated 200 times. And in a raster tile, we would just draw that thing 200 times. It's cooked into the pixels. No one cares. In a vector tile, we're storing 200 polygons in that vector tile. And all of a sudden, your tile size is much larger. So we have some tools. I'll talk about those a little bit deeper in the presentation that you can run to see where very large vertex counts exist in your data before you run creation. And that's very helpful for finding those bad data cases.
Bad data cases, and then also very helpful to help you know, is it too much data that you're trying to push into that vector tile?
Yeah, you'll have cases like really dense contours or something like that may be pushing the envelope as to what can be rendered efficiently in the GPU on devices.
We're always going back to the online basemap team and saying, you guys put too much information.
If you're a graphics developer, you'd be familiar that you'd be counting the number of triangles you're rendering on the screen, because GPUs are relatively dumb when it comes to rendering. They only care about triangles. And if you're getting into millions and millions of triangles, your map is too complex.
Yaron, our WebGL developer on this one, Jeremy, it's too complex. There's too many tiles. There's too many triangles. They got to do something.
Yeah, it's a funny one. All right, so we've actually had vector tile basemaps on ArcGIS Online since November of 2015. It's been quite a while. We've been doing continuous updates. And here I only have 8 of the styles. You'll see that some of these styles combine vector tiles with raster tiles. So in the lower left-hand corner, we have a hybrid case. That's using vector tiles to display some streets. They're semi-transparent, and labels. And that's all they're using the vector tile part for. And then they're displaying that on top of imagery. You'll also see some other cases that have hillshade. And we decided not to do a vectorization of hillshade. Some people do that. We didn't think it looked very good, and we have some very, very nice multi-directional raster hillshades. So we tend to leverage that along with vector tiles in our base maps. And I'll show that to you right now. So I have a little application here, if I can get my network to work. All right, so we have the United States. Refresh. Oh. Network is sometimes slow in this building, and then I'm over in the showcase, and I saw some guy having a video conference, and that's how you know the network is slow. But what we have here is vector tiles in the United States area, and we'll see how fast these tiles come in. And I'm going to switch between a couple different styles of these same tiles. So this is our base street map. We also have that street map with a hillshade. And in that case, when the map refreshed, it was only bringing in the new hillshade tiles. It already had all the vector tiles there, so it had to draw the hillshade and then just redraw the vector tiles, because I'm just flipping between different stylings of the vector tiles. In some cases bringing in the hillshade, in some cases I'm not. But most of the time we're just redrawing the styling of the vector tiles. And if you actually looked at the web request, you would see we're not going back out to go get those tiles, because we already have them cached locally in the browser. So I'll zoom in. I just like to go into the Vegas area. Got a nice mix of terrain here. So you'll see here that we have this multi-directional hillshade popping up through the vector tiles. And the way that that's achieved, it's a little
looks way better on Craig's laptop.
Way better on my
just
laptop.
Heddle around.
Yeah, it's a little washed out on that screen. The way that this works is that in the vector tile style, we've just made the polygons transparent. So we can have some opaque aspects of the tiles, of the style, and then the rest of it will be transparent so that the hillshade just pops through. We don't always have to mix raster and vector. We're in Vegas here, so we might want the nighttime style, since you tend to stay up all night when you go to Vegas. We also have our dark canvas style and our light canvas style. And then finally, I'll show this hybrid style. So you'll see in this case, we have semi-transparent roads, we have some highway shields, but most of it is just empty, letting the imagery show through from the vector tile. And this is some of the nice capabilities we have with the style. You can basically filter out information. You don't have to use everything that's in the tile for every use case.
I got something, Craig, along those lines.
All right.
Also a little washed out. There's another, what you'll see in, if you follow the basemap groups, so there's the out-of-the-box ones, which are all the ones that Craig showed you that are part of like your basemap gallery by default. And then the content team has a lot of other interesting ones. And one of the ones is this human geography style, and it's meant for these thematic maps. And what it does, let me turn off the thematic layer. So here I've got the base map. It's got 3 layers. It's got this sort of base, It's got the details, which would be like the roads, and it's got the labels. And with these, either in the web map or your application, you can set them as reference layers. That means they're going to draw on top of everything else. So if I make the labels and the details draw on top, and then have the base be the actual base of the base map, then when I add my own thematic data in, I get a pretty nice looking map, and I can control how much detail I want just through simple transparency. Maybe I want quite a bit of transparency, or I don't want transparency, so very opaque, because the roads are part of the story. Or maybe you want to blend the roads in because they're just sort of a backdrop on what's there. This is like simple things you can do on top of the vector tile layers that you already have. It's without having to go all the way to the style to do this. And in this case, we're drawing just with a feature layer in between. Cool.
All right, if you're interested in the Esri base maps, you might want to take a look at the ArcGIS blog and look at, you just search for vector tiles there, and you'll see a variety of blog posts written about the structure of the Esri base maps, how to enable things like labels in other languages in your own rendition of that style. We do some special things with boundaries if you need to show different representations of boundaries between countries, and really the overall structure of the layers that you'll see at each level of detail, so you can do your own styling of those. And I'll talk a little bit later about why you'd want to style our tiles rather than build your own. Before we do that, though, I want to talk about consumption. We've been able to consume vector tiles since 3.15, and actually, was it 4.0?
Yeah, beta.
4x beta. So for quite a while, at the 3.18 implementation of the JavaScript API, we moved to a newer implementation built in-house at Esri, and that was to support things like vector tiles in any coordinate system. One thing to keep in mind with the JavaScript API, you do need a WebGL-capable browser. That used to be a problem. Hopefully it is not a problem for you these days. Occasionally you'll run into driver bugs, especially on Windows, where graphics drivers have a tendency to get out of date. But we're moving forward to these modern browsers to take advantage of these modern capabilities. In ArcGIS Runtime, we've supported it since the first 100 release. And you'll use DirectX or OpenGL ES2 depending on the platform. So on Windows, you're going to use DirectX most of the time. Everything else, pretty much, you're going to use OpenGL ES2. And ArcGIS Pro has been able to render vector tiles since the 1.3 release. It's quite a long time ago. I'll note that it shares the implementation with ArcGIS Runtime. So anything that's supported in Runtime will be supported in Pro. Pro adds some additional capabilities that I'll talk about later to that. Okay, so that was sort of the background of vector tiles. We'll talk about using and styling vector tiles now. And there's kind of a couple different patterns I'd like you to think about. One is, if you're interested in using vector tiles and the Esri vector tile base maps suit your needs, just use them, and then you're done. That's the easiest way to take advantage of vector tiles. And we'll take care of hosting them. We'll take care of updating them when new data comes in and do all that work. If the Esri vector tile base maps do not work for you, take a look at whether or not restyling our base maps would work for you. This could be as simple as changing colors to do something like match your branding of your application. You might want to drop layers. If we have building footprints in the area of interest that you're making your mapping application for, and you have better buildings, you could just drop the building footprints from our base map, still use the base map, but drop them out of the style, and then bring your own buildings in. And that's a nice way to still get all the updates and the hosting from the Esri vector tile base maps, but not needing to do your own creation. And then kind of the last step is creating your own tiles from your own data. So if you have a special case or totally different style of base map, then you can create it from scratch from your own data. In styling vector tiles, there's a couple different ways to do it. The first thing that we'll note is that you have to make a copy of your hosted layer before you can restyle it. So you can't restyle the hosted tile layer itself. You need a layer copy. And you can theoretically download that style, hand edit the JSON, and re-upload it. But I would not recommend doing that. We have a couple different styling apps that can help achieve some restyling, and I'll dive into one just to show how that works. What I have here is this style app. We host this on GitHub. If you search for ArcGIS Vector Tile Style Editor, you'll find this. You log in, you select a layer to edit. I have a very simple map here with just a few layers. And on the left-hand side, you see the style spec. You'll see this layers array and all the layers in here. And you'll see things like this is a polygon layer, so it has a fill color and it has an outline color. And then we have rivers, defines the type of line cap, the type of join, and then the color. And if I want to change this thing, we'll make a really ugly river. I can change that, apply the style, and I change the vector tile layer from blue rivers to red rivers. And that's a fairly simple update. So I'm going through this style spec, finding what I want to update, and I'm updating it in this layer. Now, this vector tile set is very, very simple in that it has 3 layers. If you were to open the Esri basemaps in this editor, you would see a very, very long chunk of JSON. So Jeremy has some new additions that we're adding to the JavaScript API that can show how to make that a little bit easier.
Okay, let's get in. One of the things that was added in the last release of the JavaScript API in 4x was a hit test. Zoom in a bit. Hit test has already been in the JavaScript API 4. It's off of the view, and it works with your layers. We added support for vector tile layers in the last release. So basically, if you're listening to the hit test on the view, you'll get an event when that fires. That response gives you back a graphic with an attribute. In this case, there's no geometry or anything. It's just the attribute it's giving you back. And this attribute has a property called layer name, and that's going to be the layer name that's in your style. So if we go back to this app, here's a version of this app where I've clicked on the map and it's highlighted this admin 0 forest or park pattern. And maybe I want to make it more opaque. This is opacity. It's a little bit darker. Or on the land here, I want to change this color to something hideous. And we've really made a spectacular looking map. But really just to give you an idea that this view hit test is there to help you understand what is the style source layer that's actually being rendered. What's the style layer that's actually being rendered by ID so that you can make changes to it.
Okay, so we have kind of these 3 patterns. A is just using the tiles out of the box. B is restyling them. Right now, that's one of the applications we have. There's another application that's more custom built for the Esri vector tile base maps. And we'll be doing more in the area of styling in the future to improve the applications there. But those are examples of what's available now. And many people have been successful restyling via these applications and doing simple changes, dropping layers, changing colors, things like that. If that doesn't suit your needs, you need to get into creating vector tiles from your own data. And we'll talk about that now. You've been able to create vector tiles in ArcGIS Pro 1.2, and you could publish tile layers to ArcGIS Online, or what we now call ArcGIS Enterprise, but back in the 10.4 era was ArcGIS Server and Portal. So you've been able to publish vector tiles onto Portal since 10.4. If you used vector tiles in the early days, we had this sort of rough experience where you ran a tool called create vector tile package, and then you had to upload the package. But since the 1.4 release of ArcGIS Pro, this is all streamlined now in the share as web layer experience. And that'll create, upload, and publish the vector tiles in one step. So it's really handy for publishing and using vector tiles. There's a couple accessory tools I want to talk about. One is the share package tool. If you create vector tiles through this automated one-click approach, we'll use share package underneath the scenes, and that will allow you to upload very, very large vector tile packages over 1 gig that you can't just upload in the web browser. So that's useful, especially if you want to script aspects of the operation. You're going to want to use the share package tool. The other one is the extract package tool, and this is updated to support vector tiles. And what the share package tool will do is take the vector tile package, unpack actually the bundle content even within it, and put raw protocol buffer files onto disk. So if you want to take a look at those files and see, for instance, what their content is or which files are extra large, you can do that with the extract package tool. Now, one tool I haven't mentioned in here yet that Jeremy was referring to earlier, if you really want to sense out what aspects of your data set are large, you can either create the vector tiles and see it with extract package after the fact, or beforehand you can use the create vector tile index tool, and that will analyze your map and produce polygons, which are indicative of the tiles that will be created on disk. The earlier image I showed with the coast of California, that was an example of those polygons. And those polygons have attribution that indicates how many vertices are in each tile. And you want to look for really, really large vertex counts in that data set.
Just one thing on published vector tile packages. If you go to online, you can find all the ones that have been published to online, that are public anyway. And this is just ordered by most recently updated, just to give you kind of an idea of what these different types of ways that other people are using vector tiles to publish information.
Yeah, cool.
Yeah. You will find some of them in here that are too big and have too much data.
Geology maps
yes,
are usually the ones that I look out for.
Yes, yeah, good call, Craig. I just saw it here. Kentucky Geological Survey. It's not there. But yeah, it's kind of a fun way to see all the different types of data that people are publishing.
There you go.
Doug Curl. Actually, no Doug. He's a really nice guy. This one, I think, pushes the limit. Still not too bad, but there's quite a bit of data. You see, it's a little slow on the update.
Generally, if you're zooming into your vector tile and you're seeing the really generalized content sit there for a while before the sharper content comes in, it means your tiles are too heavy.
Yeah.
And that'll definitely occur in these cases where you're putting in really dense polygons like this.
Yep.
You'll also see it with really dense lines in some cases.
This one's just one other thing, I guess, to show is that these can also be viewed in 3D. And if you don't have text, it's pretty nice. So if we get zoomed in on the the same map in 3D. This is a heavyweight one.
You can see those triangles.
Yeah, coming in. And at some point, should all crisp up. Yeah.
Yep.
Cool. Switch back.
Okay, so what's going on in the back end after you publish a service? If you looked at a vector tile service in ArcGIS, you'll see just this little bit of a structure I want to talk about. You have the root JSON that describes the high-level service data. You know, what coordinate system is it in? What are the LODs? You'll see a tile map, and the tile map in this case is the index structure that allows us to do that overzooming. We can more efficiently request tiles. If we know if there are not tiles there, we'll check the tile map, determine if the tile is there or not, or whether or not to overzoom and reference that. All the tiles are under this tile resource, and then the resources section contains all the styling information. That includes fonts, which are prepared in a specific way for vector tiles. The styles contains the vector tile style information in JSON. Sprites is where fill symbols and point symbols are written. So we write a little sprite sheet. There's actually 2 sprite sheets, a low DPI and a high DPI one. And then info contains a giant manifest of all those.
You want to talk about the tile map work? Should be coming out hopefully in the next release.
So we are doing some efforts with the tile map to make that a bit more efficient. And the current tile map is a static single file. And you'll see when you load vector tiles, sometimes that's a heavy initial download. It is then cached on the client. We're going to be moving to a more reactive tile map so that we can request that for the specific extent. And that's going to allow vector tile layers to load much faster. So we won't see, for instance, a flash of missing content when you first load a web app with vector tiles that we'd see now if we're waiting for that tile map to download. We'll be making that more efficient by having a reactive tile map that can be requested from the service endpoints.
I might be able to, I don't think I should. But that should be coming. Oh, dead battery. Oh, it's all you, Craig.
All right. Good. Authoring maps. We'll dive into that now. So a couple things to think about. We only support feature layers with simple, unique value, graduated, or class break symbology. I will say, actually, that is wrong. We have added support for unclassed. If I could spell correctly. Live tile or live presentation editing. One of the things that we want to reiterate is that if you have a map that came from raster tile creation and you are looking to create vector tiles, you should reauthor that map. And you want to reauthor that map to limit the number of layers and limit duplication of content. And we were as guilty of this as anyone, and we promoted a pattern that actually just does not work well for vector tiles. In the raster tile heyday, we would create these caching kits that would demonstrate each LOD would be a group layer, and basically it would be a copy of layers with a definition query to further restrict content as you went through the levels of detail. And many of you copied that pattern and authored essentially an independent map for each level of detail, and then you just sent it off and cooked that map. And raster tiles didn't know any better. They're pushing everything through drawing, and you produce a little tile on the end point. That doesn't work for vector tiles. We need to process that information, have as little duplication as possible to keep the style small and to keep the content in the tile payload small. Now, that said, it wasn't easy to author those types of maps that are streamlined and multi-scale until we added a bunch of capabilities to ArcGIS Pro to help you out with that. And those capabilities are scale-dependent symbology, a concept called alternate symbols, which is a variation of scale-dependent symbology. We've added scale-based sizing, which is a nuanced thing for really fine-tuning your maps and having the size of symbols change across scales. We have another concept called display filters. That's when you want to filter out features on an attribute other than what you're symbolizing on. And we finally fixed a big old issue with scale logic that we had from the Arc Map days and brought over into ArcGIS Pro. I'll talk about each one of these. Scale-dependent symbology. Each symbol class for a unique value or class break symbology can be assigned a scale range. So the classic case for this is you have a roads layer. In the past, with your raster caching kit, you would copy that roads layer through 23 LODs and then set definition queries on each thing. Now, with this scale-dependent symbology, instead of doing that, you can assign scales to each one of those road classes. So you don't want to draw local roads at a national scale. You want to wait till you're really zoomed in at a large scale to draw those. And this really allows you to author one layer that's really smart, knows how to draw through the scale ranges without duplicating that layer through your TOC. A next nuanced aspect of that is alternate symbology. And you'll commonly see this for local roads. I'll demo this when I give a demo in Pro in a little bit. This is available for unique value symbology. And this allows you to change the entire symbol used for one or more classes in your symbology at a given scale range. So for local roads, when you're really zoomed in, you want a cased road symbol generally. But when you're at kind of an intermediate scale, you may want to just draw that as a single non-cased line symbol. And you can do that with alternate symbols. Next thing to talk about is scale-based symbol sizing. As you zoom in and out of a vector tile map, especially in runtime in ArcGIS Pro, you're not just hitting the individual LODs. You can have in-between symbol smooth panning and zooming. So when you're in between on those zoom levels, you may want to see symbols get larger as you zoom in and have a smooth transition, rather than have flashes of content as they get larger. You can use scale-based symbol sizing to do that. Display filters are another tool in the arsenal. If you want to filter out features, but filter them out based on an attribute other than what you're symbolizing on. So say you want to symbolize lakes, and you have standard symbols for your lakes, but you want to filter them out based on size, because why draw really tiny lakes that are only going to be 1 pixel on most screens at really small scales? You can just set up display filters to say, hey, if area of this is below a certain threshold, don't draw it at these scales. And really, this allows you to lighten the payload of your tiles. And actually, during the vector tile creation process, we'll filter out small symbols or small features for you, but that incurs payload on the vector tile creation side of things. If you've filtered them out beforehand, it's going to be much faster. And then finally, we updated scale logic. If you ever authored a raster basemap or tried to do a multi-scale basemap in Arc Map, you probably ran into this issue. You had layer 1, say it went from a scale of 1 to 1 million to 1 to 500,000. And then layer 2, you wanted that to take over at 1 to 500,000 and draw to 1 to 10,000. If you were in Arc Map and you're at 1 to 500,000, both those layers would draw. And that was super annoying. And the fix that everybody did for this is they changed layer 1 to draw from 1 to 1 million to 1 to 500,001. But the problem with that is if you are in between 1 to 500,000 and 1 to 500,001, neither layer drew. So you had a flash of content that wasn't there. In vector tiles, we don't want that because you can continuously zoom through the map. So you don't want to have content disappear and come back. So we've added this option. It's enabled by default since Pro 1.2, or it's technically unchecked, the option is. But what it'll allow you to do is have this behavior that layer 1 will drop out just before it hits 1 to 500,000, and then layer 2 will take over. So you can have smooth transitions between your scale ranges. All right, I am going to jump into ArcGIS Pro and show some things. So I have New Zealand here, and what we're going to do is spend most of our time with this roads layer. If I turn this roads layer on, it would draw all the roads in New Zealand, which is not really what we want. We want to filter these out so that they're going to behave well through the scale ranges. So I'm going to turn it off while I make these modifications. I'm also going to pause labeling for the time being, and I'm going to go to the symbology pane in ArcGIS Pro. And the default view for symbology in ArcGIS Pro is this standard view of your classes. But we have also this scale range view. And what the scale range view does is allow us to do that filtering of scale ranges. And I'm going to quickly move through each symbol class and set up scale ranges for these. Now, I must admit, I have a little cheat sheet next to me with each of these scale ranges. You'd probably be doing this in a more interactive, have the layer turned on, get some feedback as you move through, zoom in and out of your map, and see how well it does in terms of responsiveness and number of features. So I'm a little over halfway done. So you'll see that I've loaded in the tiling scheme for each of these, or for this map, and these stops here align with the tiling scheme levels of detail. And if you can all avoid it, I recommend staying away from using scales other than what's in the tiling scheme, because you're going to get the best possible tile results when you stay within the tiling scheme boundaries. And the reason why is we won't put the data into the tile if it's not being drawn for that tile. So if you make your transitions at clean tile LOD boundaries, we're not going to have to load extra data to the tile that's only viewable for half of its view range. Okay, 2 more. All right, so I very quickly used my cheat sheet, set up this multi-scale aspect. I'm going to turn on the roads layer now. One of the things you'll notice is that there's no symbol classes listed in the TOC other than freeway and motorway. And that's because at the current scale I'm at, those are the only ones that are visible. So I'm going to zoom in here. And as we zoom in, you're going to see more data draw. And you're going to see more classes come in. And if I go into the very local level, eventually you'll get these pedestrian paths that pop in. So what we have here is we have one layer that's efficiently filtering out road classes as we zoom in and out of the map. And we'll be able to process that efficiently for vector tiles. So that's a huge capability. Now, one of the things you'll notice that here, if you look at this map from a styling perspective, right there, I suddenly had these local roads appear. And then they're kind of dense for the appearance. So what I'm going to do is I'm actually going to take advantage of the alternate symbols. And my local roads are class 5, I believe. Yep. Class 5. I am going to add alternate symbology. What that did is it just allowed me to expand this little checkbox here. And I can basically set up a scale range in which another symbol draws. So I'm going to come in here and specify that I want this to be just a simple line. Let me go find one. Not blue, though. I've chosen blue, but I'm going to change it to gray, actually. So when we're at this scale, we see gray symbols, and I zoom in a little further, and it switches over to these white symbols. A little washed out on your screen. If I go in further, you look at these white symbols, they stay the same size. I may want to make those a little bit bigger as I zoom into the map. And that's when I want to change my scale-based sizing. I'd already enabled it for this map. You'll see here that at this scale, it's 3.5 points. At this, it's 15. I actually want to make that a little bit bigger. So now that symbol is nice and wide when I'm zoomed in that far, and as I zoom out, it gets thinner, and then flips over to being gray and then disappears. So that's kind of all those various techniques that we've added to vector tile authoring that enable us to author this one roads layer that's smart and knows how to move between all these scale ranges. And at this point, I already pre-authored the rest of this map. I am ready to create vector tiles. So I'm just going to fire that off. I'm going to go to the Share tab here in Pro. I'm going to share as a web layer, publish web layer. It's going to bring up the sharing tab in ArcGIS Pro. I'm going to choose that I want to create vector tiles. I've created New Zealand vector tiles about 20 times. So I'm going to give it a unique name. And there's some, if you go over here for configuration, there's some additional options here. I talked about indexed tiles. That's the default with their overzoom capability. If you wanted to do the flat tiles, you would do them here. If you had pre-calculated index polygons, you could also choose those there. I'm just going to accept the defaults and publish this. And creating this vector tile set will take probably a minute or so for all of New Zealand. I actually let this run for raster tiles on my laptop on one weekend. And then Monday morning came around and I needed my laptop at work, so I had to kill the process. Just to give you an idea of the difference in tile creation speed between vector tiles and raster tiles, it's quite a bit different. So while that's creating,
I got one thing on that.
Okay.
One thing on the index, just to give you an idea for the performance increase.
You gonna flip to your machine? Or?
Oh, I thought I did. No, I did.
Oh, you did. Okay.
To give you an idea on the performance increase for the tile map, this is a production map viewer with a production service, so it doesn't have the new capability. When I load, it's going to load this tile map that's 206 kilobytes. That basically tells the client where all the tiles are, but that's pretty big. That's zipped, unzipped. That's upwards of a megabyte, so it's pretty heavy, and that kind of stops before tiles can draw. In the new design, so this is on our dev server, and with that new dev service, I see that it's loading 544 bytes. Now, as I zoom in, it'll keep loading those tiles, but it's minuscule in content. So this is really going to improve the initial load of your vector tile layers, even when using this indexed approach, which makes it easy for you to cook the data.
All right, we'll talk now about vector tiles in the APIs. We've covered that a little bit already, but one thing we want to point out is that with the JavaScript API, we have a variety of samples. We've had them for quite a while about loading vector tiles and leveraging vector tile items. Jeremy just showed the hit test capability. But generally you're publishing tiles online or your portal, and then we really would encourage you to leverage those tiles directly as layer items or in web maps, load web maps. Don't forget that loading web maps is kind of the easiest way to jumpstart your JavaScript application, not building those layers in code from scratch. And the vector tile layer, we've been talking about both the 3x and the 4x API. It's available in both and works with all those published vector tiles. Keep in mind that it draws via WebGL. So you gotta keep that in mind with your customers and what the WebGL capabilities of their browsers are.
And there's not much of an API to this vector tile layer in the JavaScript API. I can do that hit test. I can set the style, and that's about it. But that's why we already have a powerful feature layer that's also drawn in WebGL. that allows you to work with your data as features. So that's our strategy to give you high performance feature layers coming for your operational data, coming directly from your feature service, fast performance WebGL in a tiled manner. There's not going to be a big vector tile layer API anytime in the future.
Yep. Do you have any additional API demos you haven't covered that you want to give?
No, that was the big one.
All right. My package is still cooking. We'll get back to that in a minute. I'm going to jump into this common questions section, and then we could open it up for questions at the end. We only have a few minutes. One of the questions we commonly get, why would I need to create raster tiles anymore? I tried to talk about this earlier. Obviously, if you have raster data or you have imagery, keep using raster tiles. But you also have to take your clients into account, what they'll be rendering in. If you're using applications that don't yet have vector tile support, and that actually does exist in the Esri ecosystem even to this day, you might still want to use raster tiles. And just keep that in mind when building those apps. Another question we get quite a bit is whether or not people can extract data from vector tiles, and I'll let you read my answer here rather than reading it myself.
Yeah, that gets into the previous point that I was also making, that if you feel like you need to extract that data from the vector tiles, well, we have a better solution for you, and that's to use the feature layers to give you access to the features.
Yeah, really, they're heavily generalized. The polygons are a mess. They actually have to overlap at tile boundaries. If you're worried about somebody restitching your data together, if they can actually write the code to do that, you should probably hire them. Can I show pop-ups for vector tiles? Not at this time, but we have this in the roadmap. The hit test that Jeremy showed is kind of the first step of that for JavaScript API. Obviously, we're working on that for ArcGIS Pro and eventually ArcGIS Runtime. I'm giving a session actually immediately after this that's the ArcGIS Pro Road Ahead, and I'll demonstrate pop-ups in vector tiles there. Can I create vector tiles for any map projection? I had an earlier slide that talked about this, but I can't reiterate it enough. We allow you to create vector tiles in any coordinate system that ArcGIS supports, which is a lot of coordinate systems. I think actually projection algorithms, it's 67 different projection algorithms, but then if you get into all the parameters that can be specified for that, it's endless. And we've supported those vector tiles in any coordinate system for quite a long time now. Another question we get is, can I project vector tiles on the fly? So people look at vector tiles, they say, hey, it's vector data, can I project on the fly? ArcGIS Pro will actually do this, but it is a heavyweight operation, and I don't expect that we'll be adding that to the other APIs, including JavaScript, at any time in the future, immediate future.
We will not.
One of the problems with projecting vector tiles on the fly is that since the data is heavily generalized, we actually have to densify everything before we reproject it. So you can think of boundaries that align with latitude lines, like northern boundary of the state of Colorado. In a vector tile data set, that boundary may actually be a 2-point line. And if you're to reproject that, we have to densify it, then project it. And we have the ability to do that in ArcGIS Pro, and we do it because it produces really, really nice output, but it is pretty heavyweight. Should I reauthor my map for vector tiles? I said that earlier in the deck, yes, and I would recommend you start by reading this help topic called Author a Map for Vector Tile Creation. And that really covers the whole workflow about thinning out your map and making an efficient map for vector tiles. Another question we get is, will Ard Map support vector tiles? And it's unlikely that we will be building that. Ard Map doesn't really have a display pipeline that's readily usable with some of the modern display capabilities we need for vector tiles. And we definitely will not do tile creation in Ard Map. Can I do server-side vector tile creation? If you're used to creating raster tile caches, a lot of that was server-side creation. Jeremy talked about this effort we're doing to create vector tiles from features. That's kind of the first thing that we're working on. And then we'll look for things like incremental update down the road from that. Sometimes people say vector tiles don't draw correctly in my browser. Is that a bug? And most of the time when I hear this question, it's WebGL support in the browser and related to the video driver on your device. Get the latest driver from your video card manufacturer is the recommendation, especially on a Windows device. Do not rely on Windows Update on Windows machines for video drivers. Windows 10 has been a little bit better about this, but I've also seen it break video drivers as well. So generally, we ask that you update your driver if you're seeing display issues first.
Craig, I got one more question. I'll just ask and answer.
Okay.
And that is, do I have to use vector tiles to get fast browser-based performance? And the answer is no. Feature layers will use WebGL. So here's all 56,000 census tracts drawn using just a feature layer. I have access to fast access to the data. So as I move this slider, it's updating. So you can get really fast performance with the feature layers that are coming out that work with your feature services for operational data, and then use the vector tiles for the awesome base maps that you have. I think we're at time.
Yeah, we're at time. I'm just going to show this layer. If you flip over, this is a layer I just published. And DS 2018, you'll know I named it that. Just created. And I'll zoom into it as we're headed out. And if anybody has additional questions, feel free to come up and ask them. So I'm in New Zealand. I got to go over to New Zealand here. And you'll see that lovely behavior as I zoom into Auckland here, where these roads will change color here. Let's see.
And it didn't take all weekend.
Did not take all weekend to create.
Yeah. All right, thank you, everyone.